My name is Mark Rubin, and I'm a dream weaver. I hope these widgets help you weave your dreams into reality. This is a story about data conversion and naming standards, but really it's a story about optimization, optimizing systems. A job I had after I had a job at Pepco, the power company in DC, was this job. I worked for what used to be called Andersen Consulting, but it is now called Accenture. I got this job because I knew they had offices all over the world, and I wanted to be like an international consultant and live in cool places and have them pay for all my stuff and have fun. I was in my early 20s. I thought, why not? Now's the time. So I got this job and immediately discovered that the first thing they want you to do in these kinds of consulting jobs back then was to be a programmer, mainframe COBOL. This was what they wanted me to do, mainframe COBOL. And at that time, COBOL is an old computer language from like, I think either the 50s or the 60s. And it's used to run large back-end systems for like, well, it used to be banking. And this was the state of Maryland, the Motor Vehicle Administration. And so the project, it was before the year 2000. So it was, I think it was like around 95, 96. The idea was we had to fix all these dates on these computers. And I didn't want to learn COBOL because even at that time, it was a dying language. When I say dying, it's still in use and it's still in operation, but it was built on old stuff and I like new stuff. So first of all, I didn't want to invest the time in learning this language that I was only going to use on this one project for the rest of my life and never use it again. And second of all, I have a hard time learning languages, especially computer languages with all different syntax and all different like grammatical structures, object structures, different structures. That said, though, I can visualize an entire software architecture, which came later as a result of the story I'm telling you now. So here's what happened. So they didn't know what to do with me on this project because I wasn't going to learn COBOL. And I was the one that said no. I guess I was likable enough to say no, but I guess pushing the edge of the envelope on like my utility at this company. And so they had a guy who was fixing computers. His name was Dwayne. Basically, he didn't want to fix computers anymore. And I can fix computers because I had a job in college where I worked at like a computer lab, fixing stuff, doing stuff, software stuff, hardware stuff. So he had a little cart, with some tools, little tool belt. So I became the computer repair guy on this project. Perfect for me because I had a little cart. I did not have a direct boss. And I pushed my cart around in this project. There was like 100 people on this project, 2 different buildings, big project, lots of developers. And basically, I got to push this cart around to every corner of this project and ask people what they were doing. What are you doing? Like, what are you working on? And I would ask the developers who were like fixing this like mainframe code, like the year 2000 code, what they were doing, like what part of like the MBA system were they working on and what did it do? What was it called? What did it do? And I asked every person this that I was pushing my cart around. So I had a model in my mind of everything that happened where they only had a model of whatever it was that they were doing. But I had a spatial model of at least the structure of all the pieces of this project from the code level. And then I also asked the managers what they managed, like what were the functions that they managed and like what were their teams doing. And that could fit together the management layer on top of the operational layer. So structurally, I understood like what people were doing, how I talked to other things, the relative importance of each thing, and the operating structure of the management team that was trying to get this thing done because we were running out of time. What was happening is back then, the year 2000, for those that don't know, the century turned. And there was a time where to save memory back in the mainframe COBOL days, if you had a date and let's say the year was 1999, you would just use 90. You would use 2 digits for the 99. But then when the year 2000 came along, if you had any math that involved that 99, which you always did, always, you'd have negative numbers, like negative dates. So the date between like 2000 and 99 is negative 99 years in the old way. And that's a problem because this system not only ran the entire state of Maryland's motor vehicle administration, it also ran their payroll system for every like check that got printed and sent out to like anybody, either who worked in the state of Maryland or like a vendor or anybody. And if this thing broke, it would break like the state, like it would be bad. And so they were investing a ton of money in upgrading the software. At the same time, they were also upgrading the actual hardware, the mainframe itself, from like an old mainframe that was maybe like 15, 20 years old to like a brand shiny new one. And so this was the project. And I was just fixing stuff, just having fun, just messing around in a low profile. But I decided that to get to Europe, I was going to fix the hardest problem on this project, the hardest one. So based on my knowledge of what people were doing on this project, there was one room that I had no idea what they were doing. And it was a room that was by itself. It was a little quarter. And there were 2 people working in it, sometimes 3. They were working on this thing. And I never understood what they were doing. And it turned out one day I asked them. And the reason I didn't know is because they were like, they were by themselves. They were like in this sequestered room and they weren't like connected to the rest of the project and like in this functional way. And so I went in there and I looked around, and in this room, there were all these shelves all the way around the room. And there was 136 2-inch binders on these shelves with words on them, like FLG001, FLG002. And I asked them, what are in these binders? Like, what is this room? They said, those binders are all the programs that run this MBA. So all the programs that other people are like working on out there that have all those dates, those are in these binders. Like the code is in these binders of like what the program is. And they said, we have like the hardest problem on this project. I'm like, what's that? I'm like, okay, here we go. I was like, here we go. Good. We, as part of the year 2000 upgrade, we're going to convert this data, take the old data, fix the dates, and then we're going to shove it on this new mainframe, the faster one. And they said, the problem is if we run these programs back to back to like unload all that data and fix all the dates, it's going to take 3 weeks. And we cannot shut down the state of Maryland for 3 weeks while we're doing this. There's only 2 windows of the year that we have. And if I remember right, it was Thanksgiving weekend, which is 3 days where everything's closed. And I think it was Memorial Day. There were only 2 chances left to do this. There was like there was a window for a test, and then there was the window to do it. And then it was like the year 2000. Okay. Like that was it. Okay. Sorry. Like that's the way life worked out at this juncture of time. And there were huge penalties for missing the date, like millions and millions and millions of dollars, because it would break the system. And they were trying to figure out a way to take something that takes 3 weeks to happen in 3 days. That was what their job was, this data conversion, migration, thing. And I asked them how they were doing it. They had been working on it for like 6 months. They'd been working on it a long time trying to figure out like even a way to do what they were trying to do. And it seemed like they couldn't figure it out. And I opened up one of the binders, 2-inch binders, just to see. And I can't write code or read code, but the first page in these binders had this information. It said the name of the program. Actually, I think it was FLG003S. And first thing I noticed, there was a naming standard, which meant each of those characters meant something. And this made a lot of sense to me. And the FLG meant that it was the flagging system. And the flagging system was used to flag licenses, flag violations, and create notices that later got mailed out, like with paper to people. So that made sense. There was a name, and the name meant something. And also had a number at the end, which was a sequence number. So 1 came before 2, which came before 3, which came before 4. And sometimes it would skip some, and sometimes they had extra letters and stuff for whatever reasons it was. And so I remember the first one that had this file called the flag master. But basically what this thing did is this piece of paper told me the name of the program, what order it was in, what files came into it, what files went out of it. It also told me how many CPU seconds it cost, how many records it processed, how many records per second, and some metadata about like particular to the mainframe of like where the file was located and like what CPU cluster or whatever it was on, different things that were defined in something called JCL. So it told me enough to know the energy cost of the program, the number of records that it processed and how fast it processed them. And it told me the dependencies of the order, what came first, what came before it, what fed into it, and what it fed after. I thought this is enough because I can visualize the number of records spatially as a spinning gear. So if something is 1,000 records and something is 100 records, there's a 10-to-1 difference between those spatial representations of the numbers. And the speed that this gear is spinning is how many records per second it is processing. And the CPU seconds is the energy cost to make that happen. The total number of records processed after a certain period of time is information. So I map to a line. And I was able to read these 136 binders, the front page. And I stacked that weekend, that was a Friday. By the time I came in on Monday, I had stacked the binders floor to ceiling in the order that's the optimal order with string connecting them. Somehow there was yarn on this or the twine on this project. I don't know how. I found some string and some tape. And I was taping, these binders together with string at different heights to show the branching, of what was in series and what was in parallel. So if something was in series, it was stacked. And then if you could branch, if you could run multiple programs at the same time because they didn't have any dependencies and they were in the right sequence in the flow, then I would stack them next to each other and then put a string to show that they were in parallel. So on the Monday, there were all these binders on the floor in different piles with different strings and different pieces of tape. They came in and they said, what's this? I said, this is the optimal order. And they were like, they were looking at me. And my boss, my boss came in and the first thing she said, she's like, what's this? I was like, oh, it's the optimal order. And of course, she says, you don't even know how to write COBOL. See, because that's the thing is like, they thought what people think about like what it is, the details often don't matter. Okay. So they said, how long do you think it'll take? And I said, 12 hours. And that was based on the sequencing of everything and the number of CPU seconds I could consume based on the flow that I had. And it took 12 hours. And later, through some optimizations, we got it down to 8. About like things like where would the file be and could the file be closer to like where the work was happening, and like there were like physical tapes back then that someone had like grab a tape and then like walk across a room and like put it in a machine. Like this is the era that this was. So it's like the closer, if you understood the layout of the map of the floor, you could even optimize to have things pre-sorted. So that was a long story, but that story really had a big impression on me because on this project, if you did something good, they gave you these little wooden tokens called tokens of inspiration. And you could trade them for like pizza or like, I don't know, whatever, like a movie rental at like Blockbuster movie theater or Blockbuster movie rental or like different things. And at leaving out some stuff, they gave me all of them. I got all the tokens of inspiration and I could trade it for like a 1-week trip to the partner's beach house, which I did. And, I guess the story was important in my life because I realized these models that I visualize, scale models of energy transfer, are not just useful for marbles and ramps. I already knew they were useful for business systems, but I see these models all around me all the time. Energy transfer. This is energy transfer. Same thing as the power plants, about supply and demand. And same thing about modeling businesses. Same thing about the distance a kid can run in one day. Time, work, energy, distance, all related in a model.